I have a 3D printer and now an xTool S1 laser cutter and engraver. I have a lot of accessories with them, but also a lot of screws, insert, ball bearing, etc. that I use for the different project. They're everywhere and they're nowhere, and of course, never to be found when I need them. I decided to create a small drawer, stackable system that I can use to be able to store all my parts easily. But of course, well, snafu moment. It didn't work the first time. I'm using the S2 S1 to create plywood, laser cut, put together, clean, without any plastic, and some 3D printed parts that I can actually put inside to store every component. This is the reason why I bought an X2 S1, to be able to have laser cut parts in wood, trying to replace the whole good plastic trays that I used to make, which are big and slow to print and also consume a lot of plastic. Today I will show you the full process using Fusion 360 Parametric system to build the tray, the stack, and the containers, and the lesson I've learned about dimensional accuracy. Everything starts with Fusion 360. I made a model completely with parameters. That means that I can change all the dimensions without having redesigning the part. The parameters that I can set in the model is, for example, the width of the tray inside, the length, the height, the thickness of the wood, the number of teeth that I want to be able to glue the part together, and all these little things. It takes a little bit of practice to get the parametric model right, as it is not that easy to do a lot of objects attached to it together and still rescaling automatically in Fusion 360. The tray is made of a 3mm plywood with an inside dimension of 240mm by 240mm. Why 240? Because it's a nice number. It can be divided by 2, 4, 6, and 8, making the creation of these little containers inside pretty easy, as it can be 2, 4, 6, or 8 centimeters without any problem, and still will be able to rescale. The stack is simply an extension of the tray in design, using also the same parametric system, except the side of the tray is 6mm to be able to sustain the weight of the stack above it without having any issues. Each corner of the tray has a small notch, so they lock to each other from the top to the bottom without any issue. There's no lock, no glue, nothing. They simply lock in place and do not move. As you put all the parts together, the tray and the stack together, with its own weight, the system is extremely stable and robust. The containers are a really simple design box with a simply 40 by 40 or 60 by 40 or something like that to be able to maintain the ratio with a wall thickness of 1.2 millimeters. It's really easy to design Fusion 360, and by using the same concept of modularity, you can set parameters and automatically resize the containers. You can create different size of container, export them, and then 3D print them. Cutting and assembling the tray and the stack is where the laser cutter is magic. It is fast, it is precise, and it makes a huge difference against the 3D printer. A few minutes to cut the parts, a few minutes to glue together, against multiple hours of 3D printing the same object. Interesting enough, it's also cheaper to do it in wood than actually doing in filament, as the filament for the moment is more expensive at the end than the wood. After gluing the tray together and 3D printing the little containers, this is where the snafu moment arrives. For some reason, the containers do not fit inside the tray. After checking all the dimensions in Fusion 360, in xTool, on the Bambu Lab printer, everything is as it should. So where is the problem? Measuring the little containers, they are actually spot on a dimension. Therefore, the tray has to be too small. After measuring the tray, I realized that the tray is not 240 millimeters inside, but it's missing about 0.5 millimeters in length and width, meaning the little containers simply cannot fit. After looking at it, it became really obvious that I forgot two things: the kerf composition and the dimensional accuracy of the machine itself. After calibrating the kerf and the scaling model in xTool, cutting and gluing the second tray that I made is actually perfect, and the little containers actually fit perfectly. Using parametric design in Fusion 360 allows me to change the tray and the stack and the containers to everything I want within seconds without redesigning anything. Just importing in xTool, rescanning to the right dimension and using the kerf composition, and the part is spot on. The big lesson in this is don't trust what it says on the machine, especially if you are working with two different machines like I do. Dimensional accuracy is important if you have two different machines. My Bambu Lab has been calibrated with all the things I can do, including the material shrinkage, but I didn't check the dimensional accuracy on the xTool S1. Now I have my tray stack. I already did multiple tray and stacks of different size to be able to start storing my things. And now I've got no excuses of having a messy environment to work. Thank you very much for watching. But now I have some sorting out to do. Snafu, but learning.